There. A little brighter, huh? Ferris wheel. Everyone likes a Ferris wheel, right?
Is this the class that's being filmed, or is it?
Yeah, I'm gonna film this one. Filming right now. It's just gonna film me. I think I'm gonna see you guys.
Spare change. Goes to English. She spelled spare wrong.
It's supposed to be an E, not an I. Extra.
Well, this class up approach is definitely not easy. They're good kids, but you can speak. They don't spell well. That's all good. I don't spell well either. Yes, ma'am. Yes, ma'am. All right. You don't need it?
I got
Thank you, dude. Appreciate that. Nice. Yeah. I guess you got the quiz on Monday, that's right. I didn't give you any homework today. I know I wanted to. I was thinking about it. I didn't want to, yeah. You weren't here. Couldn't give it to you. Yes, you're good. You're straight. Yeah, yeah, it was
I think one of the days I did that, and our first period, we got assignments. And I went back and
I think all that is like you get a parent assignment out one day, so you can like come in later.
Yeah, that's it. She told me to do that Sunday.
Yeah. Yeah. It's a big difference between excuse books and non. Probably tell. Because I'm learning too. Yes.
Well, yeah, most of the time,
Yeah. Orange was bad.
yes, they, but it's like, they don't count.
Now, did they give you a slip
They
that
don't count
says
it
you
under, but it's, they don't count.
excuse not excuse it. They don't give you a slip that says you skipped, did you? A red slip or something? Skip school. All right. Oh, all right. That's everybody. How's everybody doing today? Doing all right? You guys excited for spring break? Sure. A little bit. You guys have to be in school then, right? Anybody doing anything exciting for spring break? No.
Yep.
Yeah, what you doing, kiddo? New York. New York City or the state? Well, obviously the state, but you gonna visit the city or?
I just go to Club.
That's cool. I've been in New York. I like it. Good time of year to go. Warmer.
I'm going to the Texas.
You going with it?
No.
Oh. There you go. All right, just to let you guys know, I'm recording this. None of your faces are going to be on this video. It's just for my class. I take a class once a week at VCU with the math teachers, and I'm going to bring this video in so the other teachers can make fun of me. That's basically what I'm doing. But I'll get to make fun of them too. So don't act a fool too much. If you do, then I'll make fun of you. So don't do that. On a more serious note, today we are going to start our study of the unit circle. Anyone ever heard of the unit circle before today? You've heard the term? So how I'm going to present to you your first, well, I suppose the first viewing of a unit circle is through a Ferris wheel. As you can see, a Ferris wheel resembles a circle. is a circle that's simply rotating. Right there. Pretty cool. Let me show you a couple other things about it. I'm going to show you where this comes, where the unit circle comes into play. All right, so sorry the seats went away. Now just a boring circle, right? Boring circle. Some of the things you probably can recognize. Measurements. Pi over 4, pi over 2, 3 pi over 4, pi. Remember what measurements these are in? Radians, right. We're not going to use degrees anymore. I mean, we'll still refer to them when we need to, but from here on out, radians is where it's going to be at. This blue line right here. Dotted blue line. It's getting smaller and smaller. And it's getting bigger, but negative. See how it's 0? These are the negative values of this length right here. And this interesting length, as you can see, is being mapped onto this graph. You guys, anybody recognize what this graph represents? Sine curve. Exactly. So you can see how the sine curve is created by the circle. And this would repeat over and over, on and on. It's an interesting concept. I guess when I was in school and I was going through learning about sines and whatnot, I always equated sine with triangles. Right? Sines, geometry, sines, triangles, triangles, triangles. You don't see any triangles here, do you? I mean, there are triangles hidden within the circle, and we're going to examine that in depth. But just a circle turning around, and this distance right here is being graphed. As this distance gets smaller, so does that. So it's going up, so it gets to 0, and it starts over. Line gets bigger, so does this. And if you graph it, you get this familiar sine graph. Oh, pretty neat. Anyway, any questions on my Ferris wheel turned circle? Because now I'm going to lecture you guys about the unit circle. I'm going to break it down. I'm going to start from the basics. I'm going to start with a circle. If you could take some notes, this will be important. Because as all material that we discuss in this class, eventually you'll be quizzed on it, right? Sorry. Just the way it is. I'll go chalkboard today, I think.
Whoa.
Oh yeah, it's on. Oops.
Bro, don't bring him in this. Just because we came does not make it mean they're not senior.
Let's start with basics. We're gonna go real slow. We're gonna go slow. If at any time during this lecture you may be getting confused on something, please speak up. Let me know, hey, I don't know what you're talking about, Mr. Goulet. I'll be more than happy to explain. So I'm gonna start simple. This is a circle.
I'm telling you.
There are many circles like it, but this one is mine. Here's the center of a circle. Now, the circle by itself, we studied the circle in Euclidean geometry. No measurement, just a circle, get a center. Now I'm going to put this circle onto the Cartesian plane, or the coordinate graph. So here is where Euclidean geometry meets up with analytical geometry. Analytical geometry is simply when you put shapes onto the Cartesian plane. Unit circle, this right here, the center point. Can anybody guess what coordinate this point would be? 0, 0. Very good guess. You use your intuition. That is good. This point of the circle is the x-axis. This is the y-axis. Again, what's neat about the unit circle is, again, it's combining Euclidean geometry with analytical geometry and trigonometry. So what are the trigonometry? Well, let's start putting some more points on here first. The unit circle has a radius of 1. That's why we call it a unit circle. Unit, 1. So the radius is 1. Remember the radius is, right? From center to here is 1. From center to here is 1. From center to here is 1. From center to any point on this circle is 1. 1 what? 1 inch, 1 centimeter, 1 ruble, 1 roulette, whatever you want to call it, that's what it is, 1. But the specific unit is irrelevant, it's 1. So this point right here, what do we call this point? By the Cartesian plane, center is 0, 0, radius is 1. What would you assume this point is? 2. Well, it's got 2. It's got an x coordinate and a y coordinate.
0, 2, 0,
0, 1.
0, 0.
No, 0, 0 is the center.
1, 0.
1, 0. Very good. 1, 0. Now you guys remembering this stuff? A little rusty, but that's okay. What's this point right here?
0, 1.
There you go. The rust is coming off. Excellent. And this point right there?
-1, 0.
-1, 0. Yeah. Nice. And this point right here?
0, -1.
0, -1. On the quiz, which probably won't be till after spring break, but on the quiz, one of the main parts of the quiz is to be able to label all the interesting points on a unit circle. These 4 points right here, those are the easy ones. Don't get those wrong. It's going to get a little harder. All right. So now let's examine a point, any point on the circle. Let's just call it this point. Because of this point, let me draw a right triangle. All right, we'll label this angle theta. I like theta. You can call it what you want. Call it alpha, beta, epsilon, whatever you want. But I'll call it theta. We don't know what this angle is. But what did I draw right here?
Right triangle.
A right triangle. We'll give it away. That symbol right there. How many right triangles do you think I could draw in this circle? Infinite number of triangles. I could, couldn't I? I mean, I could draw a right triangle here. I could draw one here. Draw one there. Infinite amounts. So I'm just going to look at this one abstract, general. From here to here, we'll call that the distance x. All right, so let's pretend this coordinate was 1/2. Obviously, the x coordinate would be x, would be 1/2. That's the distance between here and here, x coordinate. And the distance between here and here is simply y. That's the y measurements. So far, so good? Now, let us examine. Now, here's where trigonometry comes into play with the unit circles. Because right now, we've only talked about analytical geometry and Euclidean geometry just being a circle. Now, let's talk about where trigonometry comes into this play. You have a triangle, right triangle. When you think of right triangles, what do you think of? Sine, cosine, all them things. At least that's what I do, you probably don't. So, let's think about sines. One more thing about the label. What is from here to here? What can I label that? It is a hypotenuse, yep. Can I give it a numerical value? Gotta be 1, right? Because radius is 1 in the unit circle. So, sine of theta. What is the sine of theta using this example right here? Remember sine? What is sine? You don't get it now. Remember sine? There you go. Well, the other way around. Opposite over hypotenuse. Okay, so what's my opposite? Y. And what's my hypotenuse? So y over 1, right? I can shorten that a little bit and just call it y, couldn't I? Y over 1 is simply y. So in a unit circle, the sine of theta is y. Now let's look at cosine of theta equals what? Remember cosine? What's cosine? X over 1, adjacent over hypotenuse, right? Theta, adjacent over hypotenuse, or x over 1. But x over 1, of course, is just simply x. So now, as you can see, I have labeled my x and my y. So no matter what point on this circle, the coordinate will always be, and here's the big one, here's the big concept. The coordinate of any point on the unit circle is cosine theta, sine theta. So whatever the angle is, as it goes all around the circle, this coordinate will be cosine of that angle, sine of that angle. So if you just take away this triangle, this coordinate is still the same, right? It doesn't change. There's no triangles involved in the circle. So let me ask you, where does cosine and sine come from? Does it come from triangles or does it come from circles? It comes from circles. Sine and cosine create circles. What makes a square a square? Lines. Lines make a square square, or a rectangle flat. What makes a circle round? Sine. Exactly. What makes a circle smooth? Sine and cosine. Just kind of an interesting concept, I understand. Any questions so far on our dissection of the unit circle? I know this is pretty exciting stuff, but it'll get more interesting. Yes. Let me define a couple more, let me define 4 more trigonometric ratios that I'm sure you've seen, or maybe not seen, maybe read, gone over in geometry. But I'm going to give you all definitions right now. The tangent, what is the tangent of my theta? Opposite over adjacent. What is my opposite? Represented by? Y. And what is my adjacent represented by? X. So tangent of my theta is y over x. But what else is y? What else equals y? Sine. So tangent of theta can also equal sine of theta. Excuse me, tangent of theta equals y over x equals sine of x over cosine of x. And I got 3 more to go. Anybody give me one of the other 3 trig ratios we haven't discussed right now? We have sine, we have cosine, we have tangent. There's 3 more. The inverse, right. You remember their names? Arctangent, right. We'll just call it a cotangent. Arctan or cotan, same. Cotangent is 1 over tangent. Or simply, if you flip y over x, what do you get? You take the reciprocal of y over x, x over y. Yeah, cotangent. You probably could have came up with some better labels for these. I didn't come up with them. So yeah, cot or cotangent of theta, 1 over tangent, or x over y. We got 2 other ones. What's the reciprocal of sine? Remember what that's called? Arc sine, yeah. What else do we call it? You recognize that? Cosecant. You ever heard of that? That's okay. Now you have. Cosecant is simply the reciprocal of sine, or simply 1 over y. We have one more. Secant. The secant is the reciprocal of cosine. 1 over x. Those are the 6 trigonometric ratios that I expect you to memorize, at least have an idea of what they mean. Really all you gotta know, these two right here, build the other ones. It's all about sine and cosine. They create circles, and they help create the other 4 trigonometric ratios. So, to recap, circle, on a Cartesian plane, near a right triangle. Within the right triangle, we can define trigonometric ratios. Our next step is now we're going to study these triangles that are interesting within the unit circle because it'll help us remember the unit circle better. Because in the end, I'm going to ask you to label these points by memory. And of course, if I just said do that, you can memorize it. That'd be kind of interesting. But it doesn't really tell me that you understand what a unit circle is. So I'm going to show you some special right triangles. And using those special right triangles, we can create the points on the unit circle. Therefore, you don't have to memorize it so much. You just got to understand these triangles. So, give me a moment. I'm going to hook up this my dot camera. Get out a piece of paper, scratch paper, whatever you want to call it, and I get a warm up for you. Yeah, I guess it's not really a warm up anymore, right? Like a mid warm up, maybe. Class assignment, maybe a better term. Some scratch paper.
I'm serious. You saw her, you know we always together. You know, it's oh, it's good. All right.
How does it look like?
You can say it now. You're not. So she likes you.
Yes.
What? Things. He's not like you. He's just going to be like things. It's okay.
I'm good on this, right? I won't erase it quite yet. I will be covering it up.
That's pretty fine.
Wow.
What are you talking about? Alright. You can move the desk right there.
Hopefully this message goes away. Man, tell me I got a dirty.
I was going to say about that.
Alright.
Oh, you just see brown?
So, everybody got some scratch paper out?
You're just unbelievable.
Yes.
Who's on the
Alright, leave your attention here on the screen, please. What I would like you to do, as you can see here, we have two special right triangles. We call them special right triangles because they have interesting properties. Their sides do. They follow certain ratios that are interesting and will allow us to build our unit circle conceptually instead of by memory. So, I gave you some given. I gave you two special right triangles and their side ratios. See the 60 degrees, and a 45, 45, 90. So what I would like you to do is express the lengths of the sides of these triangles as ratios. That means I don't want any decimals. When you use the skills that you have with right triangle skills, what kind of right triangle skills do you have? You know, what theorem do we know about right triangles? Pythagorean theorem, right? Pythagorean theorem says a squared plus b squared is c squared. You always get that as a tool for your right triangles. What other tools do we have? We just talked about it. Yeah, SOHCAHTOA, right? I'm sure you had that acronym drilled in your heads for years now. So maybe attempt this one first. Maybe start by trying to tell me what this orange side is. Give me that answer in not a decimal form, a fraction form, because we're in trigonometry now. And trigonometry is fractions and radicals and ratios and circles, no decimals. Not anymore. Yes, ma'am. This is not an easy exercise. Yeah. What I want you to tell me what the sides of those triangles are, the orange and the yellow sides. Yeah, and I've given you like one up there, so maybe you can set up a proportion. There's one way of doing it. Okay, it's a thinking kind of question. Don't be frustrated because you don't get it right on. That's one you can use. You can definitely use it. But technically, you might need. Yeah, is that hard to see? Sorry. I'll just order that. Alright. Yes, John. Yep. That's it. That's what we get. Anybody have an answer for the orange side? What would you get for the orange side? How would you get it anyway? What would you use? Could you use trigonometric ratio? Could you use any one of these? Maybe one of these? What's cosine? Adjacent over hypotenuse, right? So let me get you guys started, because I see some of you may be a little bit confused. Let me help you with the orange one. The cosine of 60 for this particular triangle, right triangle, is my my orange side over 1. Okay. I'll just call it the orange side, I'll just call it orange. Orange over 1. If I compute cosine of 60 on my calculator, you would get 0.5. Represent that as a fraction, 1/2. So the orange for the 30, 60, 90 triangle, well, even right in orange, some color coordinated, 1/2. Now tell me, could you figure out what the yellow side is now? Tell me what this yellow side is. I want the answer in decimal. I get the cosine of 60 is this over this, right? Adjacent over 1, or just adjacent. And you put so therefore cosine of 60 equals the orange side. You calculate cosine of 60 in your calculator, and you'll get 0.5. 0.5 is 1/2. So what is my yellow side in this 30, 60, 90? 9 over 10 for the yellow side? It's not 9/10. I'll give you a minute to think about it. Definitely would use the Pythagorean theorem, maybe. That's the one I'd go to. Anytime you get two sides of a right triangle, you can always use the Pythagorean theorem to solve the third. What'd you get? 1.5. 1.5, 3/2? Close. You're close. Your computation, you might have made a mistake in your computation. But there's definitely a 3 and a 2 involved. Yes, sir.
I just, it won't give me a fraction.
Yeah, that won't give you any fractions. A calculator won't. I'm gonna show you how to do it by hand here in a second. You got an answer?
No, I know how to turn it into
Yeah, you can't use the TI-89, right?
Oh, yeah.
You can't use this for fractions? Yeah.
Press math.
Just press math? Yeah. Yeah, so they use the wrong calculator for fractions. But it doesn't give you always fractions though. Because here's where it won't give you a fraction. If you have a decimal that's irrational, it won't give you a fraction out of it. Yes, sir. Square root of 3 over 2. That is correct. How'd you get that answer, Daniel?
Well, that is a ratio, and I call it a ratio. So if you have 1, I divide by 2 on each side.
Alright. So Ms. Daly used the information that I gave. You saw that I gave a correct 30-69 triangle, and he used proportions. Our proportions, 2 ratios. So what Mr. Daly did, he saw that, alright, well, I'm given 2 for my hypotenuse up there, and then square root of 3 for one of the legs. As a ratio, 2 to the square root of 3 equals, well, the 2 equals the 1, right? We're talking about hypotenuses, right? Hypotenuse, hypotenuse, leg, yellow leg. Call it x. Cross multiply, we get 2x equals the square root of 3. Divide by 2, x equals square root of 3 over 2. You can also use the Pythagorean theorem also. I won't go into that. But you would do x squared plus 1/2 squared equals 1 squared. You would solve for your variable, which would be square root of 3 over 2. So, these ratios are important. You're going to see why in a minute why these ratios are important, and they will allow us to build our unit circle with these ratios. Let's look at the 45, 45, 90. What do we know about this triangle, besides it being a right triangle? It's an isosceles triangle. Why is it an isosceles triangle? This is a 45 too, right? 45, therefore this has to be 45. 2 angles are the same, therefore these 2 sides are the same. So you think you can tell me what one of these sides equals without being a without it being in a decimal? I'll give you a hint. Use a Pythagorean theorem. And if you label this x, what would you label this side? They're the same, aren't they? X and x. So if you solve for one, you solve for both. It's an easier special triangle deal. Take a minute on that. Someone give me a distance of the orange or the yellow side, both being the same. What do you say? You don't like my right triangles? Do my right triangles bend? They don't make sense? Which one don't make sense? 30, 60, 90 don't make sense to you? Oh, how do I get a square root of 3 over 2? For this side? It's alright. Did you believe me? Math teachers never lie, do you? I don't know. Not too bad, huh? I'll go over that one again with you a little bit, right? But for now, assume that I'm not lying to you. So, anybody give me a sign for this one? What do we get? Somebody, come on. I know I got some, I know most of you guys are pretty smart. I've seen your quizzes. Probably one of my smarter classes. One of y'all need to tell me what this sign is. gonna walk you through it. I want to get past this so we can get on to the unit circle. Unless you get someone got an answer for me? Square root of 2 over 2? Anybody else get that? Nice. Bless you. So, square root of 2 over 2. Let's verify that, shall we? Let me have your attention. Pythagorean theorem says a squared plus b squared equals c squared. So therefore, x squared, bless you. Allergies are coming up, man. So far, so good? This is my 45, 45, 90 triangle. X squared plus x squared equals 1 squared. Therefore, 2x squared equals 1. Everybody see where I got that step? If there's any confusion, let me know. How do I get from here to here? Okay. 1 Chuck Norris plus 1 Chuck Norris is 2 Chuck Norrises. You ever heard that? That's how I remember it. X squared plus x squared, 2x squared. Chuck Norris plus Chuck Norris, 2 Chuck Norris. Alright, 2x squared equals 1, divide both sides by 2. I'm ending up with x squared equals 1/2. Take the square root of both sides. X equals the square root of 1/2. Am I done? Yep. Equals the square root of 1 over the square root of 2. Nice. If any of those steps that I just did are confusing you, please speak up. See how I got the square root of 1/2? X squared equals 1/2. Square root of both sides. So now I'm left with x equals the square root of 1/2, which is the square root of 1 over the square root of 2, which equals 1 over the square root of 2. But remember, we have a radical in the denominator. We don't like that, do we? We're going to simplify it. Multiplying the numerator and the denominator by the square root of 2. And we end up with the square root of 2 over 2. Are there any questions on how I got this? Is there any confusion? Please speak up. Don't be shy. I won't bite you. I won't make fun of you. Alright. So therefore, our special right triangle study, we know that this side right here, square root of 2 over 2, any questions? You got something different? Was it a decimal or something? Right? Yeah, you gotta get some decimal. And that's what the square root of 2 over 2 equals. Like square root of 2 over 2 equals 0.707. Yep. That's where the decimal comes from. Alright, moving on to the next fun exercise. I want everyone to pair up. Oh, I said pair up, you know that? Yeah, you good. You guys remember your pairs?
You can have
So go ahead, get in your pairs, match up. I'll explain the next exercise. Don't be shy.
What you gotta say about that?
He just, he's so hurt. He's turning red.
what?
His pain is coming out inside.
Alright.
He doesn't care.
Your pair right back. Who you got, partner? Who's your partner?
Josh.
This is Josh. You partner up with Josh. Josh, cool. Partner up with CJ. Miss Daly. You can partner up with Tom. You partner up. You partner up. You partner up. You partner up. And you three. You three are Mr. Teal. You partner up with Mr. Mayo. Alright, we all got a partner.
You can come with. You can be 4 if you want.
We'll give you directions right now.
You need to think, you know what?
My wife feeds.
Hey, why they got the Y?
I seem tired today. Well, on Friday, we'll you know what we're gonna do? We'll make some of them. For real.
He's gonna come.
I wish I knew how to do this.
Well, that's what we're learning now. We'll do unit
What's
circle.
up?
And then I'm gonna show you how to make the unit circle. These are directions.
How was
I wanted money. She didn't.
I did.
Alright, directions.
Oh. Yes.
But I wanted money.
How much money?
Yeah, I mean, I can find more of them. You get one per team, no matter. That's better. Yeah.
I thought like 30. I got 5. Thank you. No, I didn't.
The next thing I'm gonna pass out to you guys is a completed unit circle, alright? We are going to create a unit circle right now. I don't want you to be referencing this unit circle as you're creating it. Well, I do want you to reference it. I just don't want you copying it directly from it, basically. But here's what a unit circle looks like filled up. And on the quiz, I will be asking you to replicate this on a blank. On a blank unit circle. Definitely keep these for your notes. If you lose one, that's alright, I can play. Don't lose. Don't kill it.
I'll just take it.
No.
To go. How about just take the whole thing?
Unit circle.
I don't want that. How about
Inspired.
have you seen
Yes,
this?
look at the
Does it
unit circle. I got 5 of them right here.
It's my favorite thing. Yes, sir.
Boom.
Can you be patient? Here you go.
Thank you.
Here you go.
Alright, and one more sheet I'm going to pass back, I'll pass to you, is this. As you can see, check it out. Blank unit circle. See those interesting points? You can kind of see them right there. Alright, we have 2 triangles. Guess what kind of 2 triangles these are? If you had to guess. These are right triangles. What kind of right triangles? They're special right triangles, exactly. So what I'm going to do is I'm going to pass these out, and then I want you to label the sides of these special right triangles. I might have to show you how to do it again, but in the ratios, I want you to copy the ratios onto these triangles. With these triangles, you will create the coordinates on this circle using just triangles. And I will demonstrate it. I'll demonstrate one of them on the overhead. I'm just going to give one of these per pair. And I got some scissors for you. I'm just going to get the cuts and stuff out. It's going to be great.
Be there at 7 o'clock. See you there.
Good, good. If each team, each pair can come up and grab a pair of scissors. I'm getting kind of lazy.
I might get that. Alright.
I know, but you better bring my present then, okay?
Playing.
Okay? Bring my present then, and then everything will be.
Could you send me that, please? Oh, I said kid, I didn't say kid.
Yeah, cup triangles.
Oh, what the? Yeah, you are.
Any questions, you can do that. So, if you
Are
have
you a
any
business
questions, dial 9 first and then you dial this to reach me. No, so you better. Any,
Everybody got scissors? You good? We're cutting? I don't even got to cut out
sorry, it's a tight.
something.
So, you know,
The light color.
I'm going to demonstrate what I want you to do on the overhead. I'll just turn the plate off temporarily. Wrong one.
You are?
Wrong one.
How long does it take to paint?
Not very slow. Takes a while.
Alright. So, here's our blank unit circle. This point right here, 0, 0 on the vertex. And this point right here, I'll give you the first point right off the bat. 1, 0. You guys see the interesting points right here? Point, 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 point. And there's 3 points on each quadrant. Speaking of quadrants, let's do a quick little review. Which quadrant is this one in? If this is on the Cartesian plane, and this is 0, 0, the vertex, this would be quadrant 1,
2, 3.
got it.
Let's take the left.
Yes,
Another one.
you need another one. So, these two triangles right here, I want you to label their sides. The hypotenuse is 1. This particular triangle is a 45, 45, 90 isosceles triangle. This side right here, square root of 2 over 2, square root of 2 over 2. Right here we have a 30, 60, 90. The hypotenuse is 1. The short side is 1/2. And the longer side, square root of 3 over 2. The label, those probably use better handwriting than mine. You cut those out. Now listen up. When you guys cut these two triangles out, I want you to label the back side also. Cut them out and label the back side also. And I will demonstrate what I mean. Demonstrating a triangle being cut out. I'm very good at cutting. That's an awful job by me. So, take any one of your two triangles, and you're going to flip it over, and you're going to label the sides the same as you labeled them on the front. So this was 1, this was 1/2, and this was square root of 3 over 2. Again, this was 1, hypotenuse is 1, and both sides are square root of 2 over 2. All right. There we go. Cool, right? Don't put the little right triangle symbol. Don't make them bad as mine. So here's what I want you to do. With your triangles, you are going to create the points, the coordinate points all around the circle. What do I mean by that? You're going to figure out which triangle fits where, remembering that on a unit circle, the radius is always 1. So if I take, here's my first example. Here's my triangle right here. And look at that. It fits just right. Hypotenuse is 1. That's my radius. And look right here. From here to here is what distance? Square root of 3 over 2, right? That's my x-coordinate, isn't it? That's my x-coordinate. This circle is on a graph. X and y, 0, 0 in the middle. From here to here, square root of 3 over 2. That's my x-coordinate. Square root of 3 over 2. And what's this distance between here and here? 1/2. Hence, that's my y-coordinate, isn't it? I just labeled. And you can compare this onto the circle I just gave you. That's where those coordinates come from. A unit circle can be created by those two special right triangles. You're going to take these two right triangles and you're going to fit them all the way around. Each one of these points, you're going to label. Now, you know the four easy ones, right? I already gave one easy one. This is the other easy one. This is the other easy one. And this is the last easy. When I say easy, I mean there's ones and zeros involved. So, label all these points. You had 3, 6, 9, 12, 13, 14, 15, 16 points to label, to be accountable for on the quiz. Using these two right triangles, you can create all those points. Let me give you one more tip. When you start getting on this side, this is like negative territory for x, isn't it? This second quadrant, x values are negative. Just throwing it out there. You can use the same two triangles to create all the points. If you have any questions, I'll go around, I'll help you guys out. But go ahead and get these points labeled, all 16 of them. Using your right triangles. I want you to like think of right triangles as you're creating these points. That's where the points come from. Yes, ma'am. I'm coming. I'll wander, I'll help each group out. Now you can flip them. That's why I had you label on both sides. Okay. Which one you talking about?
I mean, that goes out, this one, this one.
Right. This one you talking about? And you can do it all around. Getting it?
I don't know what that sounds like.
How about you, ladies? Figuring it out a little bit?
I get checked. Sweet nuts. Are you gonna go? Are you gonna go?
Well, that's that point, right?
No.
Yeah. So what's the next
I
value?
don't know. It takes about I would trip in the hallway. Compete?
Yeah, you gotta cut the circle out. But you did really good cutting the circle
I know
out.
people.
Well, you got that smooth. That's good. Yeah, if you want to play.
Just a trip. You can trip. You can get back up, you can trip again.
How come you're
Yeah, you did. That's why.
Hold on.
Yeah, because yeah, this right here is for 3 over 2. And this one,
No choice, but. Is he white?
All right.
Which Ray?
Just trying,
Is it
right?
Ray?
Do you read these insides? So this coordinates, x coordinate, y coordinate, right? This is from here to here is the x, right? This is from here to here is the y. What's this between here?
She doesn't like, I would be like,
She's still my best friend.
What are you trying? What's the difference between here and here?
I'm just spit it out. You have to like. That's not good.
That's your x coordinate.
All the people in your nose,
See the links?
the why you rub your nose and go like this. Oh!
It's like on a Cartesian plane, right? X coordinates go left and right.
I had to
Y is
show.
go up and down. It's just distances, aren't they? Distance
Is
from
that
here to here.
is that
Square root of 3 over 2. That's coordinate. Distance up and down, from here to here, that's 1/2. That's your y coordinate.
but you should
You can do this for all these.
okay? I don't even know. Think about it now.
Do all these.
I get home and there's a number on there that don't know. Text me, then I'm gonna trip you. Okay?
Yeah, the radius, yeah, 'cause
You getting it?
one run is always a radius, right?
So you
See
can
that?
go
That's what your coordinates are.
Let's go too. Maybe we should wait. Wait, maybe. Maybe.
These numbers aren't made up. They may seem like it. Yep, I'm coming. What do you got?
I gotta accept it. And so, a university from my cut.
Good question.
Amazing.
On the graph, right, for fusion plane?
Gonna say something funny.
The y-axis, left to right, x. Distance between here and here, what's that distance? Yeah, it's your x coordinate, isn't it?
I just thought about why she can't take up by herself.
What's your y coordinate?
So we take the conversation.
I got a feeling.
You understand that? We're gonna Cartesian plane at this point, do distance from there to there, and then go to y coordinate. That's why we use the triangles, like, I didn't really see the distance. And these numbers don't make sense.
Well, why are you fighting over her? If she don't want to touch him, why should you let
How
them?
you guys doing?
That's that would I would break his neck.
Yeah. But see where it meets that point? That point is the distance from there to there, right, which is negative,
Break
yeah.
his neck.
You don't need to. You can if you want. Absolutely you can. Kinda like here,
You know she lives in my neighborhood.
yeah, that's fine. You can go on if you want. If it makes you see it better, that's fine. How are you three doing? You get the concept a little bit?
No, I see you, and you don't say nothing. You
I like to confuse people. Well, I do, but I want to make sure you get confused.
I haven't been to her house.
Okay, so here's your source.
A little like, if she lives in the people all over the street, near the basketball
Where the
court.
coals are.
Yeah, that's where I live. With the red truck. That's
How do you guys
That's the
get
only
it?
way I know your house.
the red truck. Yeah, the red truck isn't there, nobody knows. And then that's why I put this down. My dad
Do
just.
you understand how the triangles make the coordinates? That's the main thing. You understand that? You understand these numbers just don't come out of nowhere.
So do you want to cut this circle?
No, you don't get to cut the circle out, just the triangles.
I have a question.
Yes, ma'am.
I thought this was the same, so I'm looking at it. Not so much.
You're not seeing what? You're not seeing like where we're gonna get the connections from?
I'm just.
Alright, well, I want you to like label these pointers. See, point, 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 point.
Maybe we'll get a worksheet out.
So would this be? Would this be two? Would this be two?
And we're gonna look, yeah, well, okay, so what is this coordinate right here? That's why we're gonna use these triangles to figure it out. So for
Doesn't
example,
matter which one.
nope, but one of the two will work, only one. So that's what this, label the backside of these.
Know what you want to do?
Yeah, that's why I don't know the label.
Okay, I'll put the triangle back on.
Oh, no. She slapped me.
Wow. Gross. Don't take that gross. My grandpa owns it. Oh, what's that supposed to mean? Because it's small and black that I can have business?
What's that?
He's just coming to my family.
I did not. Oh my god.
We'll go to that. That'd be-
Chill.
Yeah, label them the same.
God.
Amazing. That's one, so the same thing. If the length don't change, right? You flip it. But you understand this part though, like all these triangles have these lengths?
Like, I understand how you did it.
Why are they square root 2 over 2 over 2? Yeah, Pythagorean theorem, because this squared plus this squared equals 1 squared. So if you square this, and you add it to this squared, that's all. Because the Pythagorean theorem says those sides. Now we choose 1 for this, because the radius is 1. That's why we chose 1 for these lengths.
So how do you know which one to use?
There's only one that fits. So for example, so this point right here, I'm trying to figure out what it is. The distance from here to here. So root 2, right? Which is your x coordinate, isn't it? For this point. So this x coordinate is square root 0 0.
Yeah, it'll be square root 2 over 2.
So this is from here to here, up and down, and that's your y coordinate, isn't it? So now you create a coordinate for this angle right here, 30 degrees. Right? Because it's a 30, 60, 90 triangle.
How you go 30?
Because we made it because of the size, because of their size. It's 1, 1/2, square root 0 over 2.
How did you want to have?
Hmm?
How did you get?
I'm going to show you. Just hold on. Hold on, Zach. Let me just show you. Here's another way of looking at it
You
here.
get it? So we
Rachel, check this out.
now or later?
Equilateral triangle. Equilateral triangle, 60 degrees, 60 degrees, 60 degrees. All right. One, length one, length one, length one. So far, so good. I'm going to cut in half. I'll make a right triangle. I cut in half. What's the measurement between here and here? 25. Well, 1/2. So 1/2. I cut this angle in half, didn't I?
30.
30 degrees, right. 1/2. To figure this one out, it's simply x, we'll call it x, right? X squared plus, or 1/2 squared, equals 1 squared, or just 1. So we continue with this formula, and we get x squared plus 1/4 equals 1. So far, so good? Let's square 1/2, 1 squared, 1, 2 squared. I subtract quarter both sides. X squared equals 3/4. I subtract the 1/4 from both sides. 1 minus 1/4, 3/4. You get that so far?